let's see matrix operations. For that, first of all, let's consider two matrices A and B. Before that, we have to import numpy as np. Now let's consider two matrices. So A is a 3 cross 3 matrix and B is also a 3 cross 3 matrix. Now let's do certain operations on this. How to find out sum first. And it is simply A plus B. Same way subtraction A minus. To find out the product of the matrices, dot command will be used. Dot. So this is the product of these two matrices. To find out transpose of matrix A, simply A dot transpose. So see here the matrix A and its transpose is here. Then to find out the determinant of the matrix, the library linear algebra is used. So np dot linear algebra dot determinant of, so the determinant of A is 2, means it is a non-singular matrix, so we can find out its regular inverse. So that can be done using the command np dot algebra dot inverse of matrix A. So in this way the regular inverse can be found out. Now to find out trace, simply use np dot trace of matrix A. So you see here the matrix, the trace of matrix A is 1 plus 5 plus 2, that is 8. In this way trace can be found out. Now to find out the rank of the matrix, we have to import matrix first from linear algebra. So from numpy import matrix rank, it should be underscore here, and then use simply matrix rank of A. So see, it is, since it is non-singular, determinant is not equal to 0, and that's why it must be a full rank matrix, that is 3. Now if we want to find out the power of the matrix, then also we have to import matrix power first and then matrix power of which matrix, say A, and its power, let's take 3. So this is the third power of matrix A. In this way it can be formed. Next very important thing that we need frequently is eigenvalues and vectors of a matrix. So for that, np dot linear algebra from dot eig of A. So here we have the array, that is nothing but the eigenvalues of matrix A, and the matrix is nothing but the matrix of eigenvectors corresponding to each eigenvalue. In this way, a matrix of eigenvectors and eigenvalues can be formed, which will be again very useful in finding out the positive definiteness of the matrix. Since all eigenvalues are positive here, the matrix is a positive definite matrix. Sometimes we have a rectangular matrix, and for that we need to find out np inverse. So let's consider first a rectangular matrix. By using arrange command we can generate it. C is equal to np dot as matrix, and since 10 elements will be there, let's consider a matrix of 2 cross 5. Now here in arrange only one R is there. So in this way we can create the matrix. Now suppose we have to find out its inverse, so P inverse we should find out. So for that, let's use the command of C. So in this way, P-inverse of a matrix can be found out. That is nothing but the NP inverse or generalized inverse of a matrix. To find the inner product of vectors, we can use the command. Let's consider two vectors first to find out the inner product. So NP dot as matrix and B is equal to again NP dot as matrix. To find out inner product, use the command NP dot inner A B. So in this way the inner product can be found. Next time we will see spectral decomposition and Cholesky factorization of the matrices.